Hello, I'm Claire Shaw. I'm here today to introduce Sens-X, our in-fuse vehicle current measurement system. I'm going to show you how easy it is to set up a Sens-X system in order to measure currents from fuse points across a vehicle or lab car. In a later video, we'll look at configuring, logging and analysing these measurements. Let's get started. On the table, we have all the equipment needed to make a complete Sens-X system. The first of these is a Sens-X SmartFuse. We offer fuses from 5 to 50 amps for use in fuse boxes with a range of speeds and sensitivities, and we also have a form factor to measure whole vehicle currents up to 400 amps with a peak of 1000 amps. Sens-X fuses can measure up to 1000 times per second, offer measurement filtering, and can output measurement data to the CAN bus at a maximum 24-bit resolution. This particular SmartFuse has a 10 amp current limit with the ability to handle peaks of up to 20 amps and can measure up to 60 times a second. It uses a real fuse in case of an overcurrent event, which simply plugs into the back of the adapter. Moving on, we have a mains adapter that powers the logic circuitry of the Sens-X system. Any supply voltage between 7 and 35 volts DC will do. We have a T-piece. This equipment provides both power and CAN communication networking for the system. For larger systems, we have other connectivity solutions. We also have our COM dongle, which is an isolated USB CAN interface adapter. We have a CP12D adapter that links the COM dongle to the T-piece. And finally, we have a computer on which the GDSP GUI is running. This is an application built using our real-time interface creation software Visual Connects, which is used to configure the Sens-X fuses. It can also be used to monitor, log and analyse current measurement data over the CAN network, although it's possible to use any third-party CAN tool to read and analyse measurements. Now we've explained what all of these items are, we can put our basic Sens-X system together. To connect the system together, firstly we plug its power adapter into the power source. We then connect this to the T-piece. We connect the Sens-X SmartFuse to any of the CP12 connectors on the T-piece. The COM dongle connects to the T-piece via the CP12D adapter to form a small CAN network. We now plug the COM dongle into the USB port on the computer. Since this fuse has been pre-configured, we do not need to use the GUI to configure it. To confirm this, a green light will flash on the SmartFuse, indicating it's been configured correctly and that we're ready to measure currents. To do this, we need to find a suitable vehicle, so let's head outside. We're going to connect our Sens-X system to the circuit which runs the windscreen wipers. To do this, we'll use a fuse removing tool to remove the actual fuse, and we can then insert the Sens-X SmartFuse in place of the fuse we've removed. We're using the in-car charge socket for convenience in this video. Other sources of power can be used instead. To analyse the current within the circuit, we will now load the Sens-X GDSP GUI. If we turn the wipers on, you can now see the current change while being monitored by the Sens-X SmartFuse. So, within a short space of time, we've set up a current measuring system and taken some useful measurements. Thank you for watching our basic demonstration. Join us for our next video where we'll be looking at the Sens-X range in more detail.